real briefly, so I'm a recovering sysadmin. I worked for about a decade in operations, and then someone said, would you like to work on a team that puts a lot of sysadmin out of those crappy jobs that you really hated? So I started working on infrastructure as a service software, which is now at the Apache Software Foundation, known as Apache CloudStack. Sadly, and especially from the first presentation, you will be disappointed if you want to see aesthetically pleasing slides. I designed very ugly slides. If it gets past black on white, consider yourself fortunate. So Puppet is great at abstracting things away, right? So we no longer need to think about packages in terms of RPMs. We no longer need to think about our devs. We say we want this package installed, and it goes and installs it. It's essentially removed a layer of complexity for us. And so I'm going to talk a little bit about abstracting that at another level. To set some background, CloudStack is an open source infrastructure as a service project. It started in 2008. They started to have production deployments in 2009. We were originally GPL v3 and have since gone through tons of paperwork to get everyone to agree to change the license to the Apache software license, and then we joined the Apache Software Foundation. CloudStack's used in production all over the place as service providers and for private enterprise clouds. The largest one I know about is about 30,000 physical nodes under a single cloud management plane at one time. So it's got a gorgeous UI, which no one in their right mind uses to do any real work, right? This is what you show your boss or you expose to an end user, but you certainly never want to do real work there, because who wants to click with a mouse to do work? So CloudStack naturally has an API, and so CloudStack will support the EC2 API if you already have a lot of tools that are using things like Photo or Yuka tools, and you want to continue to use those tools. You can do that against CloudStack. It's also got a native API, and I put a link up there. If you grab the slides, you can go look at the API documentation. But again, this really isn't about CloudStack. This is about using Puppet to abstract another layer away. So the problems, we're going to start talking about problems first. So infrastructure as a service removes a constraint, just like Puppet removes a constraint. The first constraint that infrastructure as a service removes is you no longer have to wait to get access to hardware and compute resources. They are, in the old days, and I say old days, 2 jobs ago, I certainly remember when I first walked in and needed to provision a machine that it took me 2 months to get one, which is insane. So then we have things like virtualization, which come along, and they speed that up a little bit, so we're no longer waiting on the PO for the machine to get filed for, and for the vendor to ship us something. We can have some excess capacity and make that available. And I still routinely see people who are who spend weeks still getting a virtual machine assigned. A college that's just down the road from me, I was talking to them, they've got a supercomputing lab, and they told me that it takes 2 weeks and 8 departments to get a virtual machine provision. Everybody wants to stick their finger in the pie. So infrastructure as a service hopefully automates most or all of that out of the way and gets you from days or weeks to seconds. But of course, it introduces another constraint. You have to get the machine configured in a timely manner, which is a natural fit for Puppet. Puppet handles that, handles configuration, and does that in an automated fashion. But the problem that you have is that, particularly with infrastructure as a service, you typically have these people who are not as smart as the rest of the ops folks. You have developers, and they don't understand the intricacies of the environment. They don't know why you're choosing a particular kernel or why you configure HTTPD a certain way. and they shouldn't have to, quite honestly. And hopefully you are having a configuration management system because your ops people can't even keep that in place, and you want to remove the pesky humans and the problems that they bring along. So the first problem that you really have is that while you can set a baseline, you can set things like SSHD, right? You can configure that to be the same across all the machines. It's not enough. And so really, the first big problem that you run into when you can automate all of this is how do you classify a machine? So you've got a machine, maybe several machines, right? We provision 1, 5, 50, 500 machines all at once. How do we decide what configuration to apply? Especially when it's not necessarily the ops folks who are provisioning those machines. You still need them provisioned properly. Giving a developer environment that doesn't match production is worthless, or might as well be worthless. So how do we solve the classification problem? I'm going to talk about a couple of approaches that people have used. I think this is the wrong way. Don't do dedicated images for each purpose. Do not have a dedicated machine image for MySQL, a dedicated machine image for HTTPD. That's wasteful. It's going to take you a ton of time to maintain. And yes, there are some really big names who do this, Netflix being the obvious big one. But they've spent and sunk tons of time into completely automating that. It's not worth it. There are much better tools for handling this, and Puppet is at the top of that list, in my opinion. So, how many folks are still editing site.pp or nodes.pp? Okay, that is a perfectly valid way of doing things if you're still in low two digits of nodes. If, however, you're using an infrastructure as a service platform where people can go and provision things in an automated fashion, having to wait on you and injecting yourself as the constraint in the system simply doesn't work because now you've just added yourself as the wait station, and everyone has to go through you. They have to wait on you to edit this file, and so this simply doesn't scale, right? So there's globbing. Globbing works well if you can control the name of a machine. So if you can say that MySQL star.my domain is going to be is always going to inherit a specific set of classes, that works great. Anyone in here doing globbing? A couple people. Okay. Globbing works well at a much larger level. I think that the problem comes in when you cannot control how people are naming their machines, and that is that's certainly a potential problem when you give them the level of access they get with an infrastructure as a service platform. So the next is really a building block, right? So you can have everything as the default. All the things you care about are configured, and whether you need it or not, you're going to get the Apache web server. You're going to get MySQL, and it's just there and it's configured. And if you need to use it, great. If not, well, we're just wasting bits on disk. I think this is an interesting first step, and we'll talk about how you can extend that to make that a little bit better. So, anyone using an ENC? How many folks know what an ENC is? All right, so real quickly, an external node classifier is essentially a source of truth about your environment that Puppet can go and query and say, hey, this machine just checked in, and I need to know information about it. I need to know in the end what manifests, what classes apply to that machine. So tell me the pertinent information. Some people do this with LDAP. There's a number of others, and we'll talk a little bit more about using some ENCs. ENCs are a very scalable way of doing this. The real question is, how do you populate the ENC with the right information when you're spinning up and killing machines in a very rapid fashion? So we talked about having everything as a default. If you build on that default and have essentially a case statement in your default class, you can then do tons of decision trees, and this is really simple, right? This is two choices down that decision tree. And you can then say, hey, this applies to everything, and if these facts exist on the machine, then go do that. Anyone who doesn't know what factor does? Awesome, okay. So you can do this with the standard facts. You can also write custom facts. And that's one of the solutions that we've essentially done is we've written custom facts that query the instance metadata in the infrastructure as a service platform. So on instance creation, metadata is set, and that allows us to then go and say, hey, this metadata is telling me the role that it's going to play. It's going to tell me the location and environment. So I can distinguish between production and test, QA, and I can also see the role that it's going to apply, and I can do any number of things, up to several K worth of metadata that I can then parse, and then have that so that when you have your base or default class, you can say, hey, for role web server, include the Apache web server. For role database, include Postgres. And of course, we're assuming that you're going to do something a little more fleshed out than that long term. But this gives you essentially a decision tree that says, hey, I have all of this metadata, why not go ahead and use that? You'll also notice that this is with facts. So this is specific to the machine. It means there's no real ENC that Puppet is querying. The machine is telling that to the Puppet master on check-in. While you could also very easily do it the other way and have the Puppet master querying an ENC, this strikes me as a little bit more scalable and hopefully less prone to failure. But I don't really want to talk about instance metadata and configuring instances, because that is really, while classification remains a problem for folks, especially when doing this at scale, that's not nearly as interesting as abstracting another level. So if you want to know more about doing this, I've got a couple of, there's a blog post written by Jason Hancock, and he's got some custom facts written to query instance metadata that's worthwhile to look at. There's also a video, but his video is over 45 minutes, and I only have 45 minutes, so I'm not going to be able to delve into anything that he got to in any great detail. He talks about things like, okay, I just provisioned 30 machines, and 2 hours later I killed them all. How do I purge all of those details in an automated fashion to Puppet so they're not just hanging around forever? It's definitely worth watching. I think the video is from Puppet Camp LA. He lives in right outside LA, and it's a great video. You should definitely watch it. But what I'm really concerned about is abstracting yet another level out and using Puppet to really define not just the configuration of the machines, but to actually configure the machines themselves. So some friends of mine who are also right outside of LA, at Edmunds.com, they were users of Chef. And so folks know what Knife is? Who doesn't know what Knife is? Let me ask that. All right, so Knife is, among other things, a provisioning and bootstrapping tool for the Chef ecosystem. So they've got a number of plugins, so you can provision EC2 instances, you can provision CloudStack, you can provision any host of a number. There's gazillions of plugins. So they wanted the ability to provision hosts via this plugin, with Knife, and so they also wanted to be able to define an application stack. So they wrote a Knife plugin, and there's a link to it. So this is what deploying a virtual machine with Knife looks like. Knife, CS, server, create, and then you're going to pass some details, the name of the machine, how many resources, etc. But then you can take it a step further. I apologize, this is completely unreadable, especially in the back. So this is a 7-machine definition for a Hadoop cluster. And you'll see there's some metadata about the Hadoop cluster up top, but the first real section there defines 3 zookeeper nodes. It defines their network settings and what ports are open to them, what run list, which is analogous to a class that's being included in for the machine. It's talking about how many resources it gets and the base disk image as well. And then we have something very similar for the Hadoop master, which is another node, and then 3 Hadoop worker nodes below that. And so this entire definition of 7 machines, along with how they're configured, how their networking is set up, and how they interrelate to each other, gets deployed with Knife, CS stack, create Hadoop cluster A, single line. Knife is a beautiful tool, but it's not really part of the Puppet ecosystem. So I was jealous, and I really, as much as I like the ability to go out and be able to define a bunch of machines, I've been using Puppet at 3 or 4 different employers now, and I really like the philosophy behind Puppet a lot more. So I was jealous, but life went on. Then I went to FOSDEM in 2012, and this very large mapping company came up to me, or some employees from a very large mapping company came up to me, and they said, "Hey, have you seen what Puppet's done with OpenNebula?" And OpenNebula is another infrastructure as a service platform. And I hadn't. And they said, "Well, Ken Barber, who's a Puppet Labs employee, he went and wrote this OpenNebula stuff, and it allows us to define our entire data center. We can define how the machines exist and then what configuration applies to them." And they said, "We really would like that CloudStack because we are using CloudStack at several of our data centers." So started talking to them about why, and they said, "Well, we've got a data center in China and it's largely hands-off. We have smart hands there, but we really want to be able to take care of all the provisioning. We don't want to have provisioning as a separate step. Provisioning is integral to configuration management for us. And we want to get out of thinking of machine configuration to thinking about environment configuration." And so they said, "We really want to use Puppet for this." So I immediately said, "Wow, that's great." So we've grown used to this. Define the configuration on a machine. So Bobby's server gets these manifests or these classes included on it, and that's how it's going to be configured. It is a not very scalable way of doing things, right? Because you have to first come up with Bobby's server, and whether that's physical or virtual, you have to have a way of provisioning that out and defining that exists. So what they said they wanted was not just that it defines the machine, not just that it defines a collection of machines together, because Puppet has been doing that as well, right? But that Puppet defines all the machines and defining the machines themselves as well as the configuration it's on. So this story gets a little worse. I went to PuppetConf, and I had been talking to Dan Bodie about the OpenNebula stuff. I said, it should be a pretty simple iteration. The OpenNebula stuff uses fog. It should be pretty simple for you to just change this, right? So I get to PuppetConf, and which is a great conference if you get a chance to attend. you should avail yourself of it. He shows off Google Compute Engine working, which is great. I'm thrilled that he did so, but it wasn't really what I wanted. So, you know, I've been harassing Dan for months at this point, and then he throws that in my face, and I continue night up that. So I think I kind of pissed Dan off a little bit. So to get rid of me, he tried to write a book, saying, "Hey, I'm not going to do it for you, but I'll write a book to tell you how to do it yourself. Please leave me alone." That didn't work. I told him I didn't have time. Please go do it for me now. And I appreciate the book. I actually have the book in my backpack. So then finally, right before Christmas, Dan wrote types of providers for CloudStack, and you can see the link to the GitHub. So let's talk about how this works. So I can define an instance, and obviously ensure present tells me that I want it. Change that to absent if I want to purge it. But then we have flavor, and flavor is really the set of CPU and memory and that's going to be provided to it. So you know, that may be 2 cores and 16 gigabytes of RAM. I'm defining zone, which is analogous to an availability zone in EC2, and then I'm specifying a disk image. And I can specify a host of other things, you know, what account it's on, the host name, tons of networking details, etc. I can also set some defaults. So if I know that every instance is going to be CentOS EL6, I can define that here so that the disk image is not in question. And instead it becomes a question of what am I actually telling this machine to do? And I can also, you know, naturally, as with any resource, I can override those. So that makes my instance definition much more compact. This also means I can do, and this is obviously far more readable, but also far more simple than the Hadoop example. So I can say, I can define a web stack that includes 2 machines in this instance, and then go and magically include that class and just have all the machines in the class provisioned. So I'm going to, real quickly, I'll show you a little bit about how this works. So we have a DB1, and I'll have to kill DB1 off. So the real question is, well, if you look at the dashboard, I may be, yeah, I'm getting pretty close. You can see had a couple of failure deploys because I'm so high on resource usage, but So here is a pretty simple single machine definition. And this is for the machine foo that we saw there a few moments ago. So the interesting things that I'm doing, and it's just off the screen here. So user data is commented out. If I were going to use user data, that would essentially be setting something that the machine could query. and could set as facts. And Brew is something centralized to CloudStack. So if we wanted Puppet to query, CloudStack to get that information, essentially treating it as an ENC, we would use Brew rather than user data. Relatively simple. We'll see if I have enough resources to revision something. You'll see a factor bug for some reason on my MacBook Air running in Linux. It thinks I have no IP address and cannot find one. It works fine on the same hardware under OS X, and obviously Linux running on those machines doesn't have a problem. So it still sees it's still trying to destroy that machine too. So it changed. You'll see it changed the role to from nothing to special snowflake machine, which is not the intended effect. We'll make sure the others are destroyed first. Still killing it all. So how many folks here are going to DevOps Days tomorrow while I'm waiting on things? Anyone here who wants to go, who does not have a ticket? All right, so if you'll see me afterwards, first of all, who took the last scone? Because you are not getting a ticket from me. And there was only one left, and I set my coffee down and then it disappeared. Seriously though, I have a couple of extra tickets from colleagues who are unable to make it. If you're interested, come find me afterwards. I will try and hook you up. Okay, so those are showing as destroyed now. Well, do this time. We'll try and do the others. So I've got another definition here of two instances defined in a class, and because I'm running this all locally rather than in a Puppet master, you'll see I've got an include statement up top, so that when I run Puppet apply, it automatically is going to include that class. So essentially, by calling the class, it should you get to see a factor bug again. So it just created DB1 as an instance. And it should go and create Web1 because I don't believe Web1 or the web server exists on it. Again, assuming I have enough resources left. It's very painful when your personal cloud is so few machines that you can exhaust it very easily. How it makes sense, then it's your way. So it deployed DB1, eventually wanted to error out, and then finally gets the message that there are more resources for web. And failed demo aside, that's essentially what you're looking at. And as much as I would encourage you to use CloudStack, this same type of being able to define all of your infrastructure in a public manifest exists for Open Nebula and Google Compute Engine. I would certainly tell you not to try and use the knife plugin because you want to achieve both. You should stay on the public side, which is good and pure. But not that there's, again, not that there's necessarily anything wrong, but the design philosophies are a little bit different between the two. Any questions? At all? Silence. Yes?
How would you use exported resources? So I can see you like standing up that stacking in your database server. How would you communicate that to your web?
If you would have asked me 6 months ago, I probably would have said stored configs. I think PuppetDB is the right answer now. It's much better than stored configs was. And really, you're going to have to, there's no escaping it once you start deploying 15 sets of your web stack, right? So really, once you get past number one, there's no choice but to get to start doing something, either stored configs or PuppetDB. But PuppetDB is the right answer, I think, now. Which injects a little more complexity, but if you're doing it at any scale, it's not. It's definitely worth it. So. Anything else? Did I completely fry your minds? All right. So I am, what, 15 minutes early for you? I'm happy to go and talk about anything you want. I will tell, who asked the question about why Razor instead of...
why Razor instead of Foreman?
No, not instead of Foreman. Spacewalk. Spacewalk is awful. You shouldn't even ask that question. Even Red Hat acknowledges Spacewalk is awful and is trying to get rid of it with something else. Spacewalk feels like configuration and provisioning from the 80s. And if you'll notice, mid-2000s, they started a project called Cobbler, which was wonderful. And I'm sad that Red Hat abandoned it, but that project lives on. Because they realized that, I hope it was because they realized that Spacewalk was really awful. And yes, you can see it puked all over itself. Not very well, but it puked all over itself because it didn't have enough resources. Really, it's evolutionary. Cobbler was the next level in doing that, in handling provisioning and to a degree, just touching that config level. Spacewalk's great claim to fame was that you could deploy it and automatically have your stuff registered on RHN, which it does a great job of serving as a registration for RHN, but hopefully that's a solved problem as well. The other, so I see the things that Red Hat looks to be trying to build, things like Catello that are hopefully, Robert, what's the other piece of that? Replacement for Spacewalk.
Platforms.
No, it's not platforms.
That's what we were calling it last time.
No, it's not platforms. But no, it's not ALS. It's part of Catello, right? Candlepin. So Candlepin and Catello are some of the things that they're working on to try and build a really scalable, much less painful platform for doing Spacewalk. I have no idea when that's going to come to fruition. My understanding is that they are actually working Puppet into that system, although to what level I don't know. But Razor's miles ahead of that already, thanks to tons of effort dumped into it by the folks at EMC and people like Nalley who were doing really awesome things that already have this idea of, I need to not only be able to provision machines, because provisioning is really a solved problem. We had that solved with Pixie booting in the 90s. The real thing is being able to say, hey, I need to find machines that I can use, and I need to be able to find them in a deterministic manner, and then I need to be able to consume them and potentially free them up at some point. It is to the point that Razor is almost infrastructure as a service like, because it's maintaining this database of, here are all of these machines with all of these configurations, and so if I need a machine with 16 gigabytes of RAM versus a machine that has 64, I can query and provision to that rather than wasting a machine with 64 gigabytes of RAM when I really only needed 16 for that. So it's Razor really is next generation provisioning, and just Spacewalk is really feels very 90s by comparison, and it's very painful to use. I don't know anyone who enjoys that experience. All right, anything else, or shall I just, yes?
You mentioned disliking the design philosophies of Chef. Could you elaborate on that?
So I think they made some early choices because they really wanted to do hosted Chef server originally, and so there's so much that is designed around that I personally don't like. Even though you can now run a Chef server on your own, there were so many original design considerations to that that it really just burned me early on. Having to run a client manually to do a number of things, even though some of those clients like Knife are quite beautiful now. I kind of like having that centralized puppet master as part of that design philosophy. So, there's a ton of other reasons, but that's the one that personally bit me early on and kind of sold me on doing things with Puppet. Yes?
Can I ask you a out of left field question?
Absolutely.
Do you guys run your Puppet in HA load balancing mode? Can you speak to that? Or?
So I personally do not anymore, quite simply because I no longer manage hundreds of machines. So I manage a bunch of machines in EC2, and I manage a bunch of machines in my CloudStack environment. And you saw from the list that it's no longer massive. So I do not do, I don't even try and do HA. The big challenge is typically keeping key store synced. So you're probably either having an external source for key stores, or you're doing something like replicating that entire disk with something like DRBD. So standing up a load balancer in front of it is a nice first step, and then that allows you to start adding nodes. Of course, you need to have that external key store as well. Can't get away from that. Yes?
So we don't use Puppet currently in our environment. We're using OS for provisioning, and then we probably do a lot of manual configuration management. Can you speak a little bit to, because I looked at it, and it seems like it's really geared well for Linux types of machines, but we have a big Windows presence. Can you talk a little bit about support for Windows, and how far that goes and how well that works?
So the bastard operator from hell inside me says, so Windows support is dramatically better than it used to be. So if you want to talk about managing installed applications, registry settings, services that are starting, you're fine. You need to get much below that, and life gets painful. At least that was my experience a few months ago. I will tell you I haven't done it in a few months because I have not used Windows professionally in 5 years. I no longer have. When I spin up a Windows machine, I'm spinning it up in something like EC2 because I don't have any Windows hardware anymore. And I do consider myself very fortunate to be rid of that beast. You know, I last left a hybrid environment several years ago, but I no longer have access to hundreds of machines that are running Windows, and one of the Puppet Labs employees may be able to give you a better answer. So.
Yeah, I mean, I can tell you that we have a lot of focus on it right now. We've actually hired more people to work on Windows, and it's a big focus area for us to make it better. Like Dave said, it has gotten a lot better than it was, certainly, but we're working on making it even better. We're starting to resource it more like a real operating system support.
Yeah, and if that's an interest area, I know I run into lots of customers that run, you know, heterogeneous environments, and I can add that into the demo set because I think you'll find it's gotten a lot better and more to come. But yeah,
it's still miles above anything else out there that you would use in the Windows world. Right. And really the only competition that comes close to handling it at scale that I see is Chef, right? But I think that I still think that Puppet's doing a much better job of that. Yes?
Kind of a naive question, but what's your selling points on CloudStack versus OpenStack?
Very different design philosophies. OpenStack is a perfectly valid choice for some situations, and CloudStack is a perfectly valid choice for some situations. So on the OpenStack front, it's written in Python. It's incredibly modular. So there are 8 or 9 projects right now that are considered out of the incubator. You assemble those to provide an infrastructure as a service platform. So you may combine things like Nova, and you may Cinder for block devices, Quantum Glance, and Keystone for authentication. And you assemble all of those and you make a choice as to what you're assembling. You may pull in external things like, instead of using Swift, you want to use ReactCS or Ceph, but you're essentially making design decisions about how to build that. Their design philosophy has made something that should be incredibly scalable, and if that is your focus, great. That's a perfectly valid choice, and it's also a decision about workloads because that workload lends itself very well to cloud-style workloads, right? So you have engineered it properly to expect failure. You have, if a machine dies, you hopefully aren't crying over it, and you just spin up another in its place. CloudStack takes a little more holistic, and that means also more monolithic approach to things. So rather than having a combination of Quantum and Glance and Swift atop Nova, that all just comes as CloudStack. And so it's yum install CloudStack agent for a KVM node, yum install CloudStack management for the actual management node, and that's it. If you want to do SDN, it's already included out of the box. That theoretically makes us a little not scaling. We're really starting to run into scaling problems at about 40,000 physical nodes under a single management plane, which people think, wow, that's incredible. But when you start talking about the scale that people like HP Cloud and Rackspace want to run at, that's nothing. We are starting to get to the point where we're starting to have to tease apart some of those elements because we have people who are wanting to get past that hurdle. But our default implementation will always be go install one meta package, it'll install everything for you and have you up and running, hopefully pretty simply. If that means you want to run Nicira, there's no moving, there's no swapping out Node network instead of Plum. You're instead just going to tell, hey, I'm deploying, I'm going to use Nicira, or I'm going to use Big Switch, or I'll use MyNet, or I'm just going to use old school VLANs, because it's all kind of included in the box, and that becomes a configuration option rather than a building block choice. All right, so I'm at about 2 minutes. Feel free to talk to me. I'm happy to give you my opinion, which is worth exactly what you paid for it today. And I consider my opinion right, so you'll have to put up with that too. But thanks very much. I appreciate you taking the time to listen to me.